Today we're going to learn about independent versus dependent. In an algebraic situation, equation, table, or graph, the variables, usually x and y, can be classified as either independent or dependent. The independent variable is always located on the x-axis of a graph. The independent variable is the input, that's what's going in. It can also be referred to as the domain. It is usually the x in a table or equation. The independent variable stands alone, meaning it does not depend. It can make sense all on its own. The independent variable is what happens first. Next, we learn about the dependent variable. The dependent variable is always located on the y-axis of a graph. The dependent variable is called the output, or it can also be referred to as the range. It is usually the y in a table or equation. The dependent variable depends on the independent. And the dependent variable is what happens second. I have a picture of what it would look like on a graph, and you see down here we have the independent variable on our x-axis and our dependent variable on our y-axis. Now we're going to look at some phrases. And as I read them, think before I actually put the answers into the spaces, which one might be the independent variable and which one would be the dependent variable. Student's grade depends on how much she studies. So what's happening, independent of everything else, is how much time she is studying. What depends on how much time she studies is the grade. The next one, the height of a plant and the amount you water it. The independent variable is the amount you water. And that means that the dependent variable would be the height of the plant. The height of the plant is going to depend on how much you water it. Number 3, the amount of money you make and the number of hours you work. The independent variable would be the hours that you work, and the dependent variable would be the amount of money you make. The amount of money you make depends on how many hours you work. Next, the number of sodas you buy and the total money spent. The independent variable is the number of sodas you buy, and the dependent variable would be the amount of money you spend. The amount of money you spend depends on how many sodas you buy. And the last one, the number of houses you can paint depends on how much time you have. The independent variable is the amount of time, the dependent variable would be the number of houses that you can paint. Now we're going to see how this can create tables based on words and understanding the independent and dependent variable. So our first example is about Marcus. Marcus reads for 30 minutes each night. He wants to determine the total number of minutes he will read over the course of a month. He wrote the equation T equals 30D to represent the total amount of time that he has spent reading. Where T represents the total number of minutes read, that's what T is, and D represents the number of days that he read during the month. Determine which variable is independent and which is dependent. Then create a table to show how many minutes he has read in the first 7 days. Okay, so we have two things happening here. We have the number of days and the minutes read. The number of days is the independent variable. Those are going to happen no matter what. Minutes read is going to depend on the number of days. So we're going to create our table, and we have number of days. And from the reading, it says it wants us to put in the first 7 days. And then we have minutes read. And in order to get that, we need to apply the equation from above, 30D. Remember, this is a multiplication problem, so we're going to take 30 times the number of days, because the number of days was our D. So 30 times 1 is 30. 30 times 2 is 60. 30 times 3 is 90. 30 times 4 is 120. 30 times 5 is 150. 30 times 6 is 180. And 30 times 7 is 210. And from there, you could answer questions about it and just say, how many minutes did Marcus read in 4 days? You would say 120 minutes. The last one I will do with you. Kira designs websites. She can create 3 different websites for each week. Kira wants to create an equation that will give her the total number of websites she can design given the number of weeks she works. Determine the independent and dependent variables. Create a table to show the number of websites she can design over the first 5 weeks. Finally, write an equation to represent the number of websites she can design when given any number of weeks. So we have an extra step this time. We need to actually write the equation. So our independent variable would be the number of weeks. Our dependent variable is the number of websites. So our number of websites are going to be determined or be dependent upon how many weeks we work. Notice how our independent and dependent variables become our titles of our table. So we have number of weeks, and according to our reading, we want the first 5 weeks. Okay, and then we have number of websites. Okay, so she can do 3 different websites each week. So 3 each week. So on week 1, she can do 3. On week 2, she can do 6. On week 3, 9. Week 4, 12. And week 5, 15. To figure out the equation, you have to figure out how you're getting from the independent variable to the dependent. So we are taking the number of websites and multiplying it by the number of weeks to figure out our total websites. You can use any variable that you want. So I'm just going to use D for my total, I'm going to use W for my weeks. So D was the websites was 3 times W. That's how I was getting D. I was multiplying 3 times W. Let's do one more together because this next one is a two-step equation. So we have Priya streams movies through a company that charges her a $5 monthly fee plus $1.50 per movie. Determine the independent and dependent variables, write an equation to model the situation, and create a table to show the total cost per month given that she might stream between 4 and 10 movies. So the independent variable are the number of movies, and the dependent variable would be your total cost. Her total cost depends on how many movies she watches. So again, we're going to move those independent and dependent variables into our titles. And then we have our total cost. Now, why this is a two-step equation, and it's because of this $5 monthly fee. No matter what happens, Priya is paying $5. So I'm just going to give total cost a C for my variable, and movies an M. Again, you can use any variable you want. We can fill in the number of movies based on the 4 to 10. Now each movie costs $1.50, but remember, every month we have to include that additional $5. So every month there's that additional $5. We need to take that into account and also use that for our equation.
Kathy, I forgot your key.
Okay, so I put an addition of 5 at the end there, and that's just as a reminder. I want to actually put that total cost into that table. So it is $1.50 per movie. So $1.50 times 4 would be $6 plus that 5. So she's paying $6 for the movies, but then that additional $5. So for 4 movies, she would pay $11. And then we continue working with the math. For 5 movies, she would pay $7.50, but then she'd have that $5 monthly fee. So she'd be paying $12.50 if she watches 5 movies. $1.50 times 6 would be $9 plus the $5 would give you $14. $1.50 times 7 would be $10.50 plus the $5 would be $15.50. $1.50 times 8 would be $12 plus the $5 would be $17. $1.50 times 9 would be $13.50 plus the 5 would be $18.50. And then lastly, $1.50 times 10 would be $15 plus 5 gives you $20. The last thing I need to do is to create my equation. The total cost was $1.50 times the amount of movies plus $5. That is my two-step equation that I needed every time. And so now I no longer need this over here. This was just a reminder to make sure that I added, because I don't want to leave it out there. Someone might think that I was adding $11 plus $5. And we already added the $5 after we multiplied.